All right. Well, the tide seems to have slowed. I'm sure that we'll still get a few people coming in, but it's also recorded, and they'll just miss my little intro here, I'm sure. So everyone, thank you so much for coming to the first of the monthly Automerge community calls. It's starting in the middle of summer, so I'm sure a lot of people are on vacation. So we'll see how this grows, or who actually ends up coming to them in the long term. The overall structure of these calls, at least the theory that we're starting with, is a couple presentations, just either stuff that the core team's working on or folks in the community, as a place to sort of share, and then time to discuss, just sort of open discussion afterwards. We also have office hours on Mondays at 9 Pacific for half an hour, which is, I believe, 5 Central European time. And I guess would be some horrible time in Asia, maybe like 2 in the morning or something. Um, so without further ado, welcome to the first one, the Summer Vibes Automerge Community Call. Here is the agenda for today. So intros and welcome. The hosts of these going forward are myself and Alex Good. If anybody else wants to get involved, we're more than happy to take people. And we also have 2 talks. First, Alex Good is going to talk about some of the Automerge 3 internals. And Philip Kruger is going to talk about some peer-to-peer Automerge repo work that he's been doing with IRO. And then after that, we have an open discussion, and we are going to get everybody out of here promptly on time at the top of the hour. So with that, I'll stop sharing my screen. And Alex, take it away.
All right, let me try and share my screen on Linux. You can all see the infinite regress there? Is that good? Okay, we've solved the hard bit. All right, good to see you all. I was going to structure this as structure is a strong word. I'm mostly throwing together things that we did over the last month or so, but one of those is a big one. And then I'll talk a little bit about things we're going to do. But I'll start with this one. So there's a bunch of different things that we've done in the last month that I think are worth talking about. One is Automerge 3, and I'm going to dive into that a whole bunch. Another is we've got a solid.js adapter in Automerge repo now that Chi contributed. It's not an adapter; it's actually a pretty neat thing, which I think Chi might want to go more into at some point. Maybe we could do a demo of that at some point. But it does fine-grained reactivity in solid.js using Automerge documents. This one seems tiny, but it means that you can now do inline math in a prose mirror document, which was a big deal for me. And then Automerge repo bundles is a thing I want to talk a little bit about later because I'd like to get the community's opinion on some things. And then this thing called SAMod that I'll talk about in a bit. But the biggest one was Automerge 3. So Automerge 3 is a thing we've been working on for, well, Orion really has been working on for about a year, where the objective has been to reduce the memory usage of large Automerge documents. The memory usage could be quite surprising because the on-disk representation of a document might be, say, a megabyte, and in memory it might take a gigabyte. This is like a fairly extreme version, but that can happen or could happen. And the reason for that is that we use a really, really compressed storage format on disk, and in memory we were storing every operation in the document, in an Automerge document, as a separate struct, which when you had a very large number of operations, like say you paste Moby Dick into a document, that's going to be an operation per character, which I think is somewhere in the region of 1 million characters. I'm not sure. And each of those has a whole bunch of extra metadata associated with it in memory, and it becomes really, really large. So about a year ago, Orion said, what if we just use the in-memory, the on-disk storage format in memory? And I think he claimed it would take him a month to implement at the time, and it did take a year. But it's also given us some really cool other things as well. So I thought I'd try and give you a little guide to how it works. So, right, okay. this is the Automerge code base. Um, Sitting behind an Automerge document is this thing called an opset, which is, as the name might suggest, a set of operations. And this thing used to be, where's the definition? Okay, so this is the opset here. This thing used to be a fairly complicated object with a lot of bits and pieces in it, whereas it now just has this thing in it called columns. And so the idea is that we take the on-disk format, and we pretty much just use it directly in memory. And the on-disk format is a columnar storage format. So what that means is that for each operation, so imagine a large text document, say Moby Dick again, for each character in that document, we store the metadata about the operation as a separate column. So if you look at this thing, there's a whole bunch of different columns here. But if we want to get an intuition for how this works, you can basically just focus on these two. So every operation has an ID associated with it. And then it also has some value associated with it. So if we're trying to think about inserting text into a document, you'd have these two columns, which are the ID of the actor. So that's a random number that's generated when you create the document or load a document. It's like the process identifier. And a counter, which is a number that increases by 1 every time for your local node, every time you make an insert. So when you paste Moby Dick into a document, you have to, for each character that you're inserting, you add your actor ID and then 1 more than the last counter, and you tag each character in the document with this. Because we store each of these as a column, when we're on disk, we can basically say, well, okay, you just inserted 1 million characters, but they all have the same actor. So we can say, well, represent this as a run of 1 million of this actor ID, which takes up no more space than 1 actor ID plus the count of 1 million. And then we also have the counter, we say count from 0 to 1 million, which again is two numbers. It's much, much cheaper than inserting each of them individually. And then the value here will be 1 character per entry. But then this column we gzip compress, and because so that compresses really well on disk. And then actually the gzip compression is purely on disk. In memory, it's basically 1 long array of the characters. So that means that we're storing very little extra data over just the actual content that you pasted in. There's a whole bunch of other stuff here as well. All of these kind of work in roughly the same way. And if I show you how we actually end up using this, well, actually, no, let's think about it a little bit differently. Let's start with what we do when we load this. So on disk, you've got these columns laid out in memory, typically 1 column after another. And this is where we actually, where's the load columns? When we actually load this document into memory, whereas what we used to do was have to do a bunch of complicated work, scanning all of these columns and constructing a op for each one of them. We now, for each column, we basically say, this is the data we've just loaded off disk. It's just an array of bytes. And we have a bunch of column IDs, and we know this routine here basically just says, given the metadata about these columns, where's the offset for that column in this data, and loads it. So it's doing very little work. It's because we're not trying to extract the data from this and putting it in a struct. We're just loading it into a place in memory and saying, here's where the compressed version of that column is. So this is really fast now, and actually the slowest part of loading a document now is not related to this. It's a different part, which I'll talk about in a bit. And then if we want to insert something into this document, hang on, where's it gone? Let me look up from here. All right, so here's, if we're making a modification to the document, the main thing we need to do, so when we loaded the document and we had 1 giant slab of ops that were just a single bunch of compressed columns, obviously we can't just carry this giant slab of compressed ops around once we start making modifications to it. So we need to, when we make a modification to the document, we actually split the slab of ops at the point where we make an insertion. So any modification to an Automerge document is an insertion of an operation because we never delete stuff. And so if we're trying to say insert something into a map, um, we first need to find where in the op set we're going to um, insert the operation, and then we actually perform the operation. So the first part is finding is how do we actually iterate through this compressed columnar store and find things. So here we go. Seek ops by map key says given some object ID and some key, find a bunch of data about where in the op set that operation, that key is. So all the ops for that key. And this is kind of the interesting part here. So as we break up this slab of ops by inserting things into it, we create a tree of slabs of operations. Actually, the tree is not too important here. So the main point is that all of the operations are in document order, and we want to skip ahead. And we can use the fact that we have compressed columns to skip ahead to particular places. So prop range, for example, will say this thing, given the key column, skip ahead until you find, well, no, first, given the object ID column, so all of the object IDs are in order, and we say skip ahead to this object ID, which we do by first saying the object counter, skip ahead to the counter of this object. So an object ID is the same as an op ID. The object ID is the op ID of the op that inserted the object. And so this thing is part of, and this is the new thing that Orion's introduced here, which is this crate called hexane. So hexane is a separate Rust crate, which is designed for trying to do a slightly more like this columnar compression stuff, and we're trying to remove as much as possible of the Automerge specific stuff from it. There's still some Automerge specific stuff in there, but it is feasible that this could become a slightly more general columnar compression, like in-memory columnar compression library. And this scope to value routine says, given a particular column, find the range of that column which corresponds to a particular value. And range here is literally the range of bytes. So when we do that, we say constrain this column, we get the range of this column which corresponds to the those bytes, and then we do the same within that column, scope it to the range that corresponds to a particular value. And that in turn means that we get this range, literally the range of bytes within the column that correspond to a particular property, and we can use that. So we didn't actually have to look at any of the other properties of the ops, which means that we don't have to load them into memory. We don't have to do a bunch of comparisons. And because of the ops are in memory in a particular order, we can, which makes this pretty efficient. A lot of the time we can skip directly to the couple of bits that map to a op very quickly because we haven't had to do a whole bunch of cache busting work with all the other bits of the op. Right, yeah, so that's taking advantage of the fact that we have this columnar compression. I'm not going to talk for too much longer about this because I want to talk about a few other things, and we can discuss more later. But that's the kind of the gist of it. We have this in-memory chunk of compressed columns, and we can very quickly skip through them, which is really cache efficient. But we have to do a bunch of extra work when we're mutating it. And what we end up with in general is a kind of B tree of these slabs, we call them, each of which has a bunch of ops in it. Right, cool. So that's Automerge 3. The main impact that this has had, it took Orion a year to write it. We've spent a bunch of time with the community, with you guys testing it. And now that we've rolled it out, we are seeing a bunch of cool things. So one is memory usage in general is going down dramatically, but the big impact that has had on the sync server that we run, which doesn't fall over anymore, and has I was looking at it just now, it has, I think, around, at the moment, there are 10 documents on there which have over 10 million operations in them, and it seems to be just ticking along fine. We used to have a problem where some sync messages would take 30 or 40 seconds to process, and now it's like max 70 milliseconds. So in general, this has been really good. It's made the sync server more stable. It means that um, we've got a lot more headroom before we start running into problems. So obviously people are going to start creating much larger documents now. Hang on. Anything else on that one? No. Okay, great. So that's Automerge 3. There were a few other things I wanted to talk about. What was on this list? All right, yeah, Automerge repo bundles. So this is a well, let me show you the. Okay. So Automerge repo bundles is a thing I'm working on. This is part of the latest alpha of Automerge repo, where you can export a bundle of documents from a repo. So here, this says, given this repo which corresponds to Alice, and this list of document IDs, in this case, one document ID, export this thing, which is a bundle, which can be just encoded as a byte array. And then you can send that somewhere, and you can import those same bundles elsewhere and get back the document handles that correspond to those documents. This is really useful if you want to do something like distribute an application where everyone starts with the same starting document ID and contents without them having to initially sync with each other, or you want to do something via sync via email, say. It works pretty well. I think there's a couple of bugs in it, which I want to fix, but the main thing I would like, if anyone has opinions on this API, but in particular on the implementation of the serialization. I have a simple file format down here. If anyone wants to criticize that, that would be really useful. And then a final thing I wanted to talk about is Samod, which we'll see a little bit more of in a minute. But Samod is a Rust implementation of the Automerge repo JavaScript web. Well, it's a Rust implementation of Automerge repo, which is compatible with the JavaScript implementation. But there are a few other things that it does versus the existing Automerge repo Rust library that isn't compatible with the JavaScript implementation. There are basically two problems I wanted to solve. One is JavaScript compatibility, and the other is that the existing Automerge repo Rust codebase runs everything on one thread, whereas Samod runs each document on its own thread. So yeah, I'd love it if I'm going to start documenting this thing a bit more over the next week and get people playing with it, because eventually I want to replace the existing Automerge repo Rust codebase with this so that we actually get a single ecosystem across JavaScript and Rust. But yeah, it needs some people to start kicking the tires. All right, and then I'm going to race through this. What are we doing? The major thing we're doing is sedimentary. We being me and Brooke and someone else who's joining us next month. We have this proof of concept of Belay, which is the sync protocol for Keyhive. And rather than trying to make a big bang switch over to this in Automerge repo, we're trying to pull parts from Belay into Automerge repo. And the first part of that is sedimentary, which is a sync protocol for commit graphs, but in this case, Automerge documents, which doesn't require that the document be in memory or that you have all of the hashes, you keep around all of the hashes for the document forever. And the goal here is to have something where we can have an Automerge repo implementation that doesn't have to have all of the doc handles in memory. And so sync servers can become much, much cheaper to run. So that's the first piece of work we're doing there. There's more bits that we need to pull into Automerge repo as well. And that's part of how we get Keyhive in Automerge repo. I'm also working on getting a 1.0 of the Automerge Rust crate. That's mostly, that's basically done now. There's one last thing to do and I can push that out. And then a few more prose mirror fixes. And then I also want to do some experiments with using Samod specifically to create Automerge repo in Python. I'm halfway through that one already. Right. How do I stop my share? There we go. That's me.
Awesome. Thanks so much, Alex. We'll leave sort of actually, let's do like 5 minutes of Q&A now, and then we'll move over to Philip. And then if there's time at the end, we'll leave more there. There's a couple questions in the chat for you. I've been kind of going along trying to answer them as we go, but the one that I didn't know anything about was Elliot asks, I missed what y'all did on Prosemir inline nodes, and I'm interested. Is there a place I can read more about that?
Right, yes. So the Prosemir plugin for Automerge didn't used to allow you to map a block to an inline node. So this is really specific to Prosemir, but Prosemir has this concept of inline nodes, which are parts of the document that can contain text but not other blocks. And the Prosemir math plugin uses these inline nodes to represent math within a paragraph. And so I added the ability to do this mapping. I think I added it to the changelog on the Prosemir plugin. But if not, I'll pop that somewhere. But there's a few little bugs I think still to fix there. I'm planning to, at the moment, I'm working on making the Prosemir plugin generally more stable. And I also want to make the code a little easier to understand. So part of that will probably be extracting some parts of the Prosemir logic into a common library that we might use for other rich text integrations as well. But yeah, that's the main thing there.
Nico notes that you skipped the solid.js integration section that you had in your intro slides. Anything you can tell us about those?
I reckon Chi might want to. Chi, do you fancy saying anything about it?
Uh,
If not, we can.
I don't know if I have anything to say. There is a README there in the repo in the packages, but yeah, like you said, it's a fine-grained reactive thing. You grab a hold of a document, it makes a deeply nested solid.js store that so if you care about a title on a single item in a like project and that changes, that's the only thing that's going to happen is that DOM update for that one thing. Like there's not going to be any of the other stuff is going to be applied to the store I cared about. It's good. It's good stuff. I have nothing else to say.
Thanks, Chi.
It's in the code. Everything I wanted to say, I expressed myself in JavaScript.
Yeah, it's a neat piece of kit. It should the README there I think captures most of how you should use it. It's good to go, I think.
Yeah, maybe we can put together like a post or something on the website, like a similar tutorial to the React one that shows both how to use the solid one, which will be very, very similar, but maybe tries to express some of what makes it special compared to the React one by just take an opportunity to kick React around a bit, basically.
Yes,
Really
yeah,
fun.
we definitely should do that. We should add it to the doc site.
Yeah.
Awesome. There's a couple more questions in the chat. I'll let Alex handle those async just so that we can get started with Philip, just for time. Philip, take it away.
All right. Hello, everyone. Let me share my screen. One sec. So everyone should be seeing the Iro website because, yeah, I think most people are familiar with Automerge, but when I say Iro, not everyone knows what I'm talking about. So yeah, I work on Iro, and we've recently done another like combination of Iro and Automerge. And Iro is basically a way to create direct connections between devices, encrypted ones, which is, I think, pretty cool. And being peer-to-peer, it naturally combines with CRDTs, like because you don't have a central node that is coordinating things always, you end up creating conflicts. So you often end up needing CRDTs for your use cases when you use Iro. And so yeah, we've for a long time looked into ways of making this work. So for example, we've had an Iro Automerge example that integrates Iro and just the Automerge Rust crate itself for a while. But it turns out that Automerge itself, like not that many people nowadays use only Automerge to build stuff, but they really use Automerge repo. And so we've built like an integration just a couple, maybe a month or something ago with our own Automerge repo. And then I saw the new Samad crate from Alex. And so I updated the Automerge repo example to use Samad. this is giving a little bit more overview, but essentially the difference between Automerge repo and Automerge itself, when it concerns sync, I guess, is that instead of syncing one Automerge document with another specific peer, you're actually syncing a set of Automerge documents in a whole swarm. So that's what Automerge repo gives you. It also gives you ephemeral messages and some other things. But that makes it just a lot more useful for building applications because there's a bunch of things you don't need to do anymore. It handles like connecting and disconnecting peers and forwarding messages if needed, etc. Right, and it turned out that the implementation of Automerge repo was fairly easy. This made me pretty happy. If we look at the librs file, well, I can't go there here. It's literally just you have one function to connect to a different node that is also running IRO and Automerge repo, or SAMud in this case. And you basically just tell it how to send bytes back and forth. And that's it. And then on the other side, you also accept these connections. But instead of using WebSockets, which is, I guess, the most common way of using Automerge repo or SAMud, here we're using IRO connections. So those would be quick connections that are, in the IRO case, established peer-to-peer. And so what we do is when we get an incoming connection, we also open up one quick stream where we send and receive on and essentially tell SAMud about it and let SAMud take over and do the rest. And the same thing when we connect, basically, it's just the opposite way of doing this. And so this example is out there for anyone to check out if they want to. It's also been like there's also been quite a lot of contributions from Rob Alves, who's in this call, I think, recently. So big shout out to him. And yeah, if you want to play with this, it's basically a CLI where you can set a bunch of keys and values on the document, or create documents, observe documents, delete them, print them, whatever. And you connect basically different nodes between each other. But I wanted to take this a little further. And so I went ahead and integrated this with something that Alex wrote recently, which he calls Glyphcaster. And Glyphcaster is essentially just a GTK app that shows you a text editor. And it's quite crucial that it's a GTK app because this allows us to do basically native things that IRO needs, like opening sockets and sending UDP messages, etc. This just makes it a lot easier. You can also use Tori or whatever, and then have something else for the front end than something native. But in this case, this just makes it like building native apps is just a little easier if you want to use the full power of IRO. And so Glyphcaster is basically kind of works like this. It uses IRO Automerge repo to connect SAMud and IRO together. And then underneath SAMud, there's like Automerge running, and Glyphcaster uses the Automerge stuff as well. And I can give you a quick demo of what that looks like. There we go. That's on the wrong screen, one sec. Here we go. So here I have a simple document. I can edit text, and I currently have no peers connected, but I can open up another instance of this. And when I do, I get two editors that are both connected, and I can edit text and it updates on both sides. And if Alex is ready, I don't know if he is, he can also connect to this node here, and we'll see him maybe be able to edit stuff. Let me know if you're ready, Alex.
I'm just connecting now.
All right.
The demo gods are not with us. Hang on, let me try rerunning it.
All right. Let me see if
I'm-
I might need to give you a different. Let me give you. Oh yeah, actually, everyone can try this if they want to, but this is the latest command that you need to use. Oh yeah,
Aha.
there we go. Just a different command. Yeah, sometimes, well, I often use ephemeral node IDs. And so essentially node IDs are what identifies nodes in the arrow world. So instead of IP addresses, you dial public keys, essentially, is what those node IDs are. And I use ephemeral ones, so I just re-roll them sometimes when I restart applications. And in this case, I usually use yeah, if you're in Linux, Brooke's saying this correctly. It does work, and technically it does work on Windows and macOS, I think. But yes, it uses GTK, so you need to install all of those libraries via Homebrew, via MinGW or something, whatever. So I think it's a little more involved than other systems. But yeah, we can see this is Alex here. And in this case, he's connected to us directly via IPv4, even though I'm here in my home network and I'm behind NAT. And I suspect Alex is too.
I am indeed. Yes.
And so, yeah, this IRO basically hole punched the connection for us, and we use the most direct connection we have. Looks like, so I'm in Mannheim in Germany, and this is fairly close to Frankfurt if it concerns latency. And I guess Alex is about 50 seconds away from Frankfurt too. 50 milliseconds, I should say. And so if you're typing something, oh yeah, you already said hello. Hi, Alex. Right. Yeah, you see Alex cleaning up the thing. All right,
There's a
so
question in the chat that is relevant to having this exactly as it's set up. Why
this
does the
is
other window only show one peer?
this is a very good question, and this leads me right next to to my I will answer this question as part of this presentation, I guess. But it's a very good question. So first, to explain what's happening here, usually or most people, when they do Automerge, they use the Automerge sync server or some Automerge sync server. They don't have to. This is the cool thing about Automerge. You can do peer-to-peer sync, but at the moment, most things use WebSockets. I think there's WebRTC things as well. Then this wouldn't look like the topology wouldn't look like this, but with WebSocket sync servers, it usually looks like that. And so you have a bunch of editor instances, and they all connect with WebSockets to one sync server. Every one of these here runs some version of the Arrow Automerge, sorry, not the Arrow Automerge, the Automerge repo protocol. And they exchange messages like this, and the sync server Automerge repo ends up being like a forwarding thing to talk to other editors. But in the arrow case is actually a little bit different. So the topology can look crooked like this. Let's say this is the first editor that I opened. And I gave someone a link to connect to me. And they use this link, and now we two are connected by an IRO connection. Then someone else joins, and they also share a link to someone else, and now they join, and now we have this weird topology. So this is kind of what's happening. So if, let's say, this were Alex, and this was my first editor, and this is my second editor, then Alex and the second editor aren't actually connected. This is why my second editor didn't show Alex as a peer. So this only shows the very direct connections. But it still works because Automerge ends up Automerge repo ends up propagating any changes that happen. So if this editor does any changes, I can actually demo that. If I go in here and change something, then not only does that update my other editor, but this also updates Alex, who's not even connected directly. The reason we have it like this is not because this is inherently useful or nice to be connected in this way, or just like, I don't know, at the end of the day, if some of these connections get severed, and we've not carefully set up the connections that we end up having here, then of course we get a network split, and that's not ideal. And there's ways to get around that. We just haven't integrated those yet. For example, you could use the IRO gossip crate that we have to establish essentially a random network with other peers, where you're just trying to get any 5 or 6 connections with other peers, but also not get too many connections to not get overwhelmed, but like have some healthy interconnected network. Essentially, yeah, exactly. You're building. I think it's not a plum tree. I think this is a Hyperview. So plum tree would be the paper / protocol that's used to send messages in an efficient way, or essentially build a minimal spanning tree over a network of nodes. And like Hyperview is essentially establishing a set of random peers in a bigger network that is constrained to like 5 or 6 or whatever your choice of number of peers is. And then maintaining that over time. And reconnecting to backup peers in case you're losing connections, etc. Right, so this is not that, but like in theory, you could build these kinds of things with it, and Automerge repo would just continue working. Right, so I think that answered the question. Yeah, I'm like super happy to have people check this out or contribute. Rob contributed successfully recently, so you can do it too. I can also go into a little bit of detail what happens here in IRO, right? So essentially, when you create a connection with IRO, I just told you that essentially I'm behind a home network and Alex is behind a home network too. What does that actually mean? Why is it so hard? Why does everyone connect to the cloud and some public IP address servers instead of directly to someone else at home? Well, the reason is firewalls, right? So our home routers don't let outside traffic go in, except if we had outwards traffic. There's more complexities to it. There's carrier grade NATs. There's symmetric NATs versus what is it called? Full cone NATs, whatever. It's complicated, but essentially it's firewalls getting in our way. And the rule of thumb here is we can do outgoing stuff and then get a reply, but we can't have the outgoing stuff come into our home networks first. So what IRO does is it tries 2 things simultaneously. We have a relay fallback because not in all cases you'll be able to create a direct connection. But if we're using the relay fallback, you'll see it in Glyphcaster. Here, currently, we have a direct connection. If it were using a relay fallback, it would say relay here. And we also try to send directly via IP. And so we do, when we establish a connection on one side, essentially out of band, we need to share some information about what the relay URL is that we want to reach the other thing at, and what the list of IP addresses is that we could try initially. And at the moment, we use DNS for that. In practice, we actually only share the relay URL, and the list of IP addresses get shared in an encrypted way via the relay, so the relay doesn't even know about them. Well, in theory. And then we essentially connect both things at the same time when we try to make an IRO connection. And what will happen naturally is we'll get stopped by the firewall on the other side. And then the other side will hear about this via the relay though. And because of that, it also tries to ping the other side back. And this pinging back and forth helps to break up these firewalls and essentially allows data to flow directly. And once data is flowing directly, we turn off the relay. So this doesn't cause duplicate traffic and unnecessary data use. And we keep sending pings back and forth to make sure that those connections stay open. if there's a NAS rebinding, or if you change Wi-Fi to cellular or something, you end up re-hole punching, falling back to the relay in between. It all happens seamlessly, and yeah, you don't really have to think about it as the application user. The only case where connections break is when you have 30 seconds of silence on a connection by default, but that's also configurable. Right. So yeah, that's basically an overview of, or like a fairly scratching some deeper parts of Iro, and a demo of like our Automerge. Yeah, if you have any questions, feel free to shoot them. Or if you try to run this and hitting some issues, then please let me know, and maybe we'll be able to get some more people here onboarded.
Amazing. Thanks, Philip. So this is the, at least in the schedule, the time for open discussion, but that also then means that there's also time for questions on both this and Alex's presentation. So anyone who wants to ask questions, this is a great time. Unmute or use the raise hand, and we can call on you, whichever works for you.
While we wait for people to do that, I do want to say that the Glyphcaster code base was mostly written by Claude, and I do not stand by it. If you look at it and you're like, what the hell? That was the robot.
Similar things go for the stuff I added.
Any time reading it, I think, what the hell? That is the bit the robot wrote. Like, I just guarantee you.
You could call it a good excuse, maybe. All right, I can paste the links to the examples and the code, by the way.
Alex, I wanted to say, I think the guys of Peer2Panda, they did also GTK client for Automerge. You should check with them.
Oh yeah?
Oh, that sounds very cool.
You know them,
take a
maybe,
look.
Philip, no?
Yeah, we know them. I know the Peer2Panda folks also are using Iro, so.
Yeah, I mean, the Glyphcaster thing was very much a what can I throw together in half an hour rather than how would be a good way to do this. So yeah, it would be good to talk to people who've actually built a good usable text editor.
Maybe we should have them on too, if anybody wants to reach out.
Yeah, I can drop them a message if they're still using Automerge. For some reason, I thought they had switched to something else, but it would be good to talk to them.
This is the editor you're referring to, Nico, right? Nice.
Neat.
So I have a question for Alex. Do you remember what we talked in Berlin, the removing of the hashes from inside Automerge and putting it somewhere else? Do you have any progress on that? Did you think about it or have a plan for it?
I think we will eventually do it. It's the so for everyone else's benefit, the Automerge at the moment has fairly baked fairly deep into it the idea that change is identified by a hash, and this means that, in fact, maybe this is a good place to talk about this. The main place where we use a bunch of memory and compute now in Automerge is when we load the document. We do this super fast, just read the buffers off disk and into memory, quickly iterate through them once to check that they're valid. That's really, really fast. And then we spend absolutely ages rebuilding the hashes of all of the changes that were in the document. And this causes not only that like a bunch of extra CPU work, but it also creates quite a large peak memory usage because we have to actually reify all of those changes, which, like, say you were typing and you had a change per keystroke, the change metadata is going to be massive compared to the on disk document format. So why do we have all of these change hashes? We have them because they give us this nice Byzantine fault tolerance property because it's a hash linked graph of changes. But it feels like that particular, like especially given the work we're doing on sedimentary and Keyhive, that particular piece of functionality could be a separate layer that isn't running in process every time you load the document, but is happening, say, when you receive a change, you validate it once, and then after that, you don't need to do this work. In order to do that, we'll need to change the way that the Automerge API works so that instead of using a change hash to refer to a change, so like the points in time or to run the sync protocol, it uses some like a change ID, which would be an actor ID and a counter. So that's what Nico's asking me about. The path to actually get to there is, first off, we need to do the work we're currently doing on implementing sedimentary-based sync and making that a alternative sync protocol that Automerge can use natively. And then we'll need to review the rest of our APIs to figure out where we can replace those things with change IDs. We'll need probably an overlap period where we do both, and then a breaking version at some point where we switch to just change IDs. That's one part. That's the kind of API migration part. The other part is we need to now have some kind of concept of storage because we don't want you to load changes without verifying them. So we want to have some way of saying like, you're loading a change, and this is one that I've verified. It's in storage and it's verified in some way, and exactly what those APIs should look like and whether it's something that you do manually or whether storage is a kind of concept that we introduce into Automerge. I don't know. So there's quite a lot of work to do there before it's a thing that we can use, but definitely on the roadmap.
Great, thanks. Okay. Everybody has learned something on the internals, but yeah, I'm looking forward. Thank you.
Ziklag, have you got your hand up or am I? Yeah.
Yeah. So I was curious, is that, so then if you're splitting that like verification out to a second layer, right? Then is that perhaps feasible to integrate with like other CRDTs? Because like that was one of the challenges with Loro when I first started looking into like, can you put Loro on sedimentary? Because it has like that, you know, obviously this kind of same structure of the commits and whatnot, but then because of those pure IDs instead of hashes that were used for, which is I think a lot of how it gets its performance. Loro's got a lot of performance tricks. The hashes would probably bomb out a lot of its performance tricks. But if you could do that in a separate layer, then that would be pretty handy possibly for integrating other CRDTs if that was possible.
Yes. So I guess the way that I've been thinking about what we're trying to do with Keyhive and sedimentary is authenticated and authorized commit graph transmission. So if you can build something on top of a commit graph, then Keyhive and sedimentary should be able to do the work of shipping it around and authenticating and authorizing what ranges of the commit graph particular people have access to. So yeah, I guess there's a long way of saying yes, but I think that probably would be.
Yeah, let me add a little bit of additional nuance to that because we've now wandered into Keyhive territory. So if anybody's ever looked at the Keyhive code, you'll see that it's parameterized like out the wazoo. There's just like, you know, one of them is called content ref as opposed to a hash. So it says actually nothing about there being a hash at all. It could be just as easily a vector clock or, you know, any of these other systems. You just have to have some way of ordering stuff. And we say, we don't really care how you order the content, but just like plug that in here and it will just work, right? In sedimentary, as a layer above that, we said, at least for first version, we'll see if people complain, you know, all of these things. We're going to restrict it to 32 bytes just to make it more concrete. It just gets to be a lot when you have all, you know, I think we have like 7 or 8 parameters at the top level in Keyhive. It just ends up being a lot. And you can always take your actor ID plus counter pair and hash them, or otherwise turn them into 32 bytes. So that was part, or XOR them together, or however you want to do it, as long as they're unique, right? And if you then have a lookup table that says, hey, here's how I go from these hashes back to the vector clock, then that is one simple way of making that work. The other way is that if enough people complain about it, we could parameterize it, but then it makes it much more difficult to interoperate with a generic sync server.
Okay, cool. Because yes, actually that separate lookup table, that might have been something that I was missing because, or like in Loro there was I was facing the need to, okay, get these hashes out of Loro, but then it doesn't necessarily need to be in Loro as long as it's can be validated. So that was something I hadn't yet considered, was having this like sidecar or lookup table along with Loro that would let Loro be, and that's actually a pretty simple solution then at that point. So that's very cool. Like that. Sounds good.
Other thoughts people have or questions?
We didn't get updates from you. From the
From me?
Kihai. Yeah, from
Yeah.
I mean from Kihai, from the your part of the puzzle.
Yeah, I can give you sort of like the 2-minute update. Very little has happened on KeyHive internals in the past couple months here. I was off basically, and now that I've been back, I've actually decided to. We've been talking about sedimentary and all these other parts. I'm essentially cross training on sedimentary. So Alex and I co-designed the system, but I'd never actually touched the code. And now that we're going from proof of concept to productionized version, I'm helping out on the sedimentary side, and we have some more work happening on the KeyHive internals starting September 1st. Being kind of like hand wavy about that because we can't talk about some stuff yet. And we also are working with somebody on formalizing the KeyHive algorithm, which is pretty exciting. But just like parts of it, just to get started, just to see. Which is actually going to be a big part of my day later today, is I need to review some pseudocode to make sure that it's that is correct. That I'm a couple weeks behind on getting to the person doing the formalization. Yeah, and actually, having had to think through that for the formalization, I actually think that we can simplify the algorithm a little bit. The one thing I'll say about it is we had originally started from a theory that we were going to use an op-based CRDT, and then it ends up looking more like an access control list, and you have a little bit more structure where you're cross-linking between like, well, then we added this person, then we added that person. You can think of it more as a log. But because we have a capabilities system under the hood, which I'm not going to explain on this call, but basically it deals more with paths of authority. Who invited you? And we only really care about that one path. It doesn't matter if Alex was added and then I was added, or I was added and then Alex was added. Like, we're both added to the group, right? So we don't need to know anything about that ordering. So if we remove that ordering, it actually simplifies the picture a bit, and we get something that's more like a state-based CRDT. And then we actually have to do a lot less calculation. We don't have to do topological sorts, any of this stuff. And so we can actually just like rip out sort of the hardest parts of what's currently in there. So I think we actually might be able to simplify it down a little bit, which would be pretty cool. And Alex is nodding because I haven't told him any of this yet.
I'm trying not to cheer.
Yeah. And the BChem, which is our concurrent version of TreeChem from messaging layer security, I very much want to break that out. I get DMs and emails every couple of weeks, somebody saying like, hey, could you please break that out for us? We could really use it. I would also like to do some empirical performance testing on it. We have a little bit of that that John wrote in the original implementation, but I would like to do a standalone implementation and then like really test it and see how it behaves at different scales. I've seen some benchmarks on TreeChem up to about 1,000 members, but both TreeChem and BChem target up to 50,000. So I'd like to see what that curve looks like.
Cool, super. Can I ask the formal proof? You're gonna do it with TLA Plus or with which language?
I'm pretty sure it's in Lean.
In Isabel.
Oh, it's Isabel, isn't it? Yeah.
Isabel. Yeah.
Yeah.
So the researcher has built a basically a library on top of Isabel for doing hash linked primitives. And yeah, so on top of Isabel. Awesome. I had
Awesome,
promised to get
yes.
everyone out here on time. So thank you, everyone. I'm sure that we could talk for quite a bit longer. Please take the discussion into the Discord, which is listed right there, third from the top, if you haven't seen it before or haven't gotten in there. The next of these is on September 24th at the same time. So it's still a Wednesday at the same time slot. And will be, I think it's the third Wednesday on average every month in the same time. So it's easy to book around. If we have, I believe, one talk already booked for that, so we have space for one more. Maybe maybe you'll be the my next victim. And yeah, sign up to the Luma for future updates. I believe you can sign up to the entire series. You can also use the they have like a calendar that you can just subscribe to and it just gets sucked directly into your calendar. But you do have to actually hit the button for I'm actually attending this event. I'm attending that event. So go into Luma and say, yep, I'm going to do this one. I'm coming to that one. We have had one person so far go through and just hit all the buttons of like, yep. So anyhow, thanks everyone. And looking forward to seeing you all next month.
Thanks, folks. Great to see you.
Thank you.